just part A is the Poisson sign is minus rho times 0. Right, and then take the Fourier transform on both sides. And so and when you take a Fourier transform, you call the Fourier transform of psi like capital psi. That is as long as you way back to k. So the Fourier transform with the Laplace then becomes minus k squared psi, capital psi, right? Then the right hand side should be just whatever the rho. What the other way? I'm just want to use the same. I think it's use K as well. And the Fourier transform of Fourier transform of the charge. This is the charge density. GR and GR. It just use it with a K with a T symbol, whatever, huh? Let's use another one. It's kind of strange. Let's just use this is rho, this is capital, right? If we transform that comes out K and epsilon 0. And take the Fourier transform on both sides. Equation solve the Fourier transform for psi. And obviously psi is just divided this k squared the other side. Okay. Right. And now this is the change to k squared. Right. So that should be just part A. Things like that. Right. That's kind of straightforward. And part B will be carry out the inverse Fourier transform. So psi will be whatever you call it, inverse Fourier transform of that is basically this inverse Fourier transform of that. That is 2. And now you have all with a Fourier transform k squared. You can regard it as also a Fourier transform. This is like the multiply to Fourier transform and do an inverse transform. So that becomes a convolution k squared is RK. And that case e to the, I think your text will use minus convention. Right. And that becomes a convolution. And now it depends on what the finding the transform of with the k square. And what is if f is 1 over r, that is from the example of 20.4.1, we saw that is if f is 1 over r. R is the 3-dimensional radial coordinate, which is just square root of x squared plus y squared plus c squared. And the Fourier transform of that is just copying from the example. 4 to have a squared. So this is the Fourier transform of whatever that this one, or you can combine other factor, and uh, that becomes a convolution. The, no, the rest is, this is simple. This is this is the R is the capital R is the Fourier transform of rho. But we can keep that. We can fix all that. Say like this one plus this one is this one plus this one. We can multiply by 4 pi and divide it by 4 pi, right? And so the whole thing, this coefficient multiplied by this one is the Fourier transform 1 over R. Now we do the convolution, right? And now we keep this as R, the integration variable, right? What we call it R prime, or so you have to R prime, right? And then now this K, this thing is 1 over R. 1 over R is the distance. Now we do a convolution, would be whatever R minus R prime. I actually should keep it. This is R. This is okay, right. And then into R prime. Oh yeah, this is not. This is the Fourier transform of rho cap charge density rho. Okay, that should be the answer for part B. Like, because this is general, it's not giving you the form, so that's the most general form. You still need to do an integration for unknown rho function, the charge density function. So that becomes a formula for whatever charge density. Just do this integral and solve for your psi function.